Hey guys, welcome to a new video. In this video, I want to show you my new battery box. This is my battery box 2.0. Previously, I made this DIY solar generator battery box that uses a 35 amp hour 12 volt lead acid battery. This battery box is very affordable and works well for small electronics. I still use this battery box all the time, and I'd recommend it to anybody who wants to make a battery box on the cheap. I'll put a link of how to build it at the end of this video. This is my new battery box. I wanted something that fit in the same footprint, but had much more capacity than lead acid batteries. I decided to design a DIY 4S lithium iron phosphate battery. Lithium iron phosphate batteries are much more power dense than lead acid, so you get much more power in the same amount of space and weight. In this box is 80 amp hours of power, more than triple my previous battery box. Let me show you how I put it together, and all the parts you need to build something similar. Stay tuned for more. Okay, so before showing you guys the build process, I just want to show you some of the features that this battery box has. So looking at the front, you can see that I have installed a 12 volt socket, voltmeter, and 2 USB ports. And they all kind of have these covers to keep the dust out. I have an on-off switch just for this front panel, so the 12 volt socket and the USB ports and voltmeter are all controlled with just this switch. I have an internal switch inside that controls the entire positive line, so if I am wanting to shut the battery off, I can turn it off from the inside. Looking down here, you can see I have Anderson PowerPole connectors. These are pretty cool because they hold 30 amps, and the connection is really secure. Like, you can snap in and out very easily. Let me show you some of the adapters I have for that. Now I have the 4 pairs of Anderson PowerPole connectors so that I can use these adapters. Now I've made these adapters, and basically what they are is just Anderson PowerPole to something else. So you can see this one is to SAE. These two are both to XT60s, female male. These are to 12 volt sockets in case I need another 12 volt socket, male and female. And also I have a barrel connector to charge my battery charger. And then also I have a splitter, so if I want to add an existing or maybe even have 2 sources come into one, any of these can just plug right in the front and it works well. So instead of having like all these different ports on the front, I put Anderson PowerPole and then adapt to them. Now this is an example of all 4 adapters plugged in, and I still have the 12 volt socket and USB ports on the front. So it just allows me to use many different connections, inputs and outputs to the battery. The first thing you see looking inside the battery case is this circuit board here. Lithium iron phosphate batteries need some protection for temperature and over discharging and overcharging. So you have to get a BMS. There are a lot of very cheap BMSs out there, but I would not trust them. And you want to make sure you have a BMS with low temperature shutoff. So looking on the market, this is one of the best BMSs that you can get. I have it linked in the description below, and there's 2 places you can buy it. You can buy it in the US from Overkill Solar, or you can buy it from AliExpress in China. AliExpress in China is about 70 bucks, and Overkill Solar is about 115. They're the same exact unit. The main thing you need to know about a BMS is it does a few things. It protects the battery from over discharging so that you can't run it too low. It protects the battery from overcharging so that you don't hurt the cells by overcharging them. And it also protects the battery by balancing each cell. There's also on this BMS a low temperature cutout. There's a temperature sensor that goes around, and I have it taped to one of the battery cells back there. For lithium iron phosphate batteries, they cannot be charged below freezing. So 32 degrees Fahrenheit, 0 degrees Celsius, you cannot charge this battery or it will do permanent damage. So you want to make sure your BMS has that sensor to shut off charging, and this one does. And one thing that I really like about this is it has a Bluetooth module and an app so that you can monitor this through your smartphone, and it has every bit of information you'd ever want to know. Pretty happy with it so far. Been testing it for about a week, and it's worked flawlessly. Okay, so I was thinking about when I built this, and I think it might look a little complicated for some people, so I want to include some wiring diagrams. The first wiring diagram is specifically for the BMS, the BMS balance port. So these balance wires hook into the battery at 5 different places, and it reads the battery voltage on each cell. It's important that these are all the same exact length, so the resistance in the wires are the same, so each cell is read the same. So when you're going to install this cable, I did shorten it by about 6 inches, but just make sure every single wire is the same length and that you follow my wiring diagram to hook it up. The second wiring diagram that I want to include is for the entire setup. Looking in here, you can see there's just a ton of wires, and it might be a little hard to see, where everything goes. So I thought it'd be helpful to include a diagram that shows how everything connects and how the front panel is wired in, how the Anderson power poles are wired in, how the BMS is wired in, and so forth. If you guys have any questions about these wiring diagrams, please feel free to put a comment below in the video, and I'll try to get back to you. I've tried to make this as simple as possible, so it actually is fairly simple. It's just a tight area, so everything looks like it's a wire's nest in there, but it's pretty simple. Okay, so first thing you're going to want to do is put all your batteries in parallel to get them to be the same level of charge. So you just hook all the positives together and all the negatives together. And just let it sit like this for 10 hours or so. Okay, so I'm using this 3M VHB tape. I'm putting 2 layers of it between each cell to hold them together and also give an air gap for cooling. So you can see there we have an air gap between each cell. And then they're now layered in series, so positive, negative, positive, negative. Go ahead and get them hooked together. Okay, you can see I'm using 2 longer screws for the terminal, the main positive and negative terminals. Okay, so here's the assembled 4S battery. So we have our main negative and our main positive. And then it goes positive, negative, positive, negative, positive, negative, positive. These little wires here are the balance lead for the BMS. When you are doing this, you need to make sure that you do not contact any of the other leads together. You do not want to short circuit the battery in any place, so be very, very careful when you are assembling the battery. Okay, so I have the battery assembled with the BMS attached to the negative. This BMS is designed to go on the negative terminal, so you have a battery negative on this side and a charging negative on this side. So this basically becomes your negative lead. Okay, so I wanted to show you how I'm going to mount it into the box itself. So I cut out this piece of wood. You can see it's just spray painted black, and it's cut to go around the outside of the battery. So I just cut it to the dimension of the box inside, and basically just gives it a snug fit so that the battery's sitting in the case, it doesn't move. I put my 100 amp fuse switch here, and have my positive terminal that's just going to go straight to this lead, and then all my positive connections are going to connect here. So that'll give me a fuse connection and power switch if I want to turn it off. And then all my negatives are going to hook over here on this side of the case. Okay, a couple more thoughts before I go ahead and put it in the box. You can see here I have my BMS on top of my battery, but I have it divided by this foam here so that there's no, so if the BMS does get warm, it doesn't affect the temperature of the cells. Also just maybe give it some padding and some free movement without it going anywhere. The other thing is, to avoid short circuits, you're going to want to cover up all these extra terminals. So I just put some electrical tape on them. I shouldn't really have much going in and out of this box. Like once it's in there, it should just be fine and left closed. But just in case something does come loose or hit something, I don't want any short circuits. So I did tape over these. And just especially when I'm working with this positive terminal next to these, I just really want to have that covered. Also, when I'm installing, I put over some heat shrink just temporarily to sit on this negative terminal so it will not hit the positive terminal of the battery. Okay, so I just wanted to show you guys the front panel wiring setup before I install in the box. I figured it'd be a lot easier to show you the layout here versus when it's in the box, when it's all kind of shoved and crammed in there. So this is what's going to be on the front here, all controlled by this on and off switch. So 12 volt, voltmeter, and USB sockets. So if you look at the back here, you can see that all the positives are tied in together and all the negatives are tied in together. The negatives will go onto the BMS negative terminal, and then all the positives go through this switch because I do not want this powered all the time. I just want to power it when I want to see the voltage or run one of these two things. So it goes into the switch, and then I have it fused, and then this will go and terminate at the positive terminal. I did run out of the 12 volt socket, I did run 12 gauge wire. So you can see there's one thick wire here, one thick wire here. And then as it comes to this point here, this is all 12 gauge wire as well. So the voltmeter and USB ports is just the stock 18 gauge that comes with it. So it shouldn't have any problems with voltage drop or anything there. I'm going to terminate all my negative connections to a 5/16 bolt. So I just used this 5/16 ring terminal and soldered all those into it. So there's that, pretty simple. Okay, so this is my Anderson PowerPole 4-pair kind of panel that will be on the front of the box. So basically it allows me to plug in 4 connections, and this is the wiring for it. So these are the pins for the Anderson PowerPole, and then I have these are 12 gauge wires that terminate to a ring terminal, the 5/16 ring terminal like before. So basically all my negatives are just going to attach to one nut on the BMS terminal. So you can see there's these just plug straight back into the negatives on the back of this, so pretty easy there. The positive side, what I decided to do was go with 12 gauge wire here. You can see these are all crimped on to the end here that go into this panel. So all those wires all go into the panel here. And then I have those all terminating to this 10 gauge wire with a built-in fuse. So I do not plan to run more than 40 amps or 30 amps over this as a whole, but I did go with 10 gauge wire here just to be safe, and I have a 30 amp fuse in here, and this will terminate to the positive side switch that will just turn the whole battery on and off. So there's my Anderson PowerPole wiring setup. Fairly easy. Just all the negatives go into one place, all the positives go into one place. The front panel, so this here, the positive will terminate here as well, and the negatives will terminate here, so they will be tied together. Okay, so I'm looking at the front of my box here, and I've marked the places that I want to drill. Now the tape is a little bit uneven here, so it looks like it's slanted, but it's level as I think I can get it. I've marked the center hole for each one of these, and the 12 volt socket and everything, they use a 1-inch diameter hole saw. So I'll remove this panel now that I have those dots in there. I'll remove this panel and then drill out these holes. And then the power switch uses a 1/2 inch diameter drill bit. So I'll drill this hole and then drill these 3, and then I should be able to mount everything on here. The last thing will be a little bit more complicated. This Anderson PowerPole panel, you have to, I'll start first by measuring or tracing out this, and then I'll expand the edges until it can pop in, but that will be, I think I'm going to have it right here. I might offset it too, so it leaves me, for the future, I can put something over here. So we'll see. But that's how I get all this installed. Should be pretty easy drilling out these and that, and then get it all in there. Okay, you can see it makes quite a mess, but all the holes are drilled. You tighten them from behind, but you can see you get a little bit of free play to straighten it the way you want. I'm going to pop this out. Yeah, there's the 3 holes and the hole for the switch. So that's like the most stressful part, ruining this brand new case to put the panel on. But hey, we got it. Okay, so that basically gets us to where we're at right now. Let me go ahead and give you the dimensions really quick. It's about 9.5 inches wide, 15 inches deep, and about 9 inches tall. This one here weighs 20.4 pounds. My heavier lead acid battery is the same exact size because it uses the same case, but that weighs 26.4 pounds. So this is 6 pounds lighter, so it just helps it be a little bit easier to carry around. Okay, with this section of the video, I want to show you how I plan to use this new battery box that I've made. One of the most important ways I use this is camping. So if you think about camping, one of the best things to do is have a fan with you, especially if it's a warmer night. And I found one of these O2 cool fans. This is a DC powered fan. It runs off 6, I believe, D batteries in the bottom, but you know, those batteries are super expensive. So I actually saw that there was a barrel plug on the side here, so it actually runs off of 12 volts, and it's pretty sweet. So there's a low setting, so low setting works pretty good, and then the high setting is basically like a tornado. So amazing fan. This battery box will run this thing forever. So DC fan, perfect thing to run off these battery boxes. The next thing that I would recommend and that I plan to use is this smart charger. This is a MiBoxer C4, and so this does any battery that you can think of rechargeable battery wise. So it does the 18650 batteries, which are lithium ions. It does lithium iron phosphate, nickel metal hydride, so you know, rechargeable end loops, things like that. And it adjusts to size. So this is a great charger, and what's awesome about this is it runs off of AC or DC input. So that's, you know, remember this adapter that I had? Plug that in, plug it in there, and you're good to go. So that's that. So this here is another thing I plan to use. So this is the BESTEK 300 watt pure sine wave inverter. I was blown away by this. This is a Amazon $45 special, and it is, for the cost, this is a pure sine wave inverter, and it works. Like, it is tested and tried. It has a ton of positive reviews. It's, you know, the quality, it's super heavy. Like, this is the real deal, and I was just blown away. So anyway, it has 2 power outlets, AC outlets, and then some USB ports. has a fan to cool it off. Anyway, this is an awesome inverter if you're looking for one that's cheap, but it's pure sine wave, so it doesn't hurt your electronics. So with that inverter allows you to charge tool batteries. Like this is my Bosch rechargeable battery, 50 watts, right? So I could charge my tool batteries in an emergency, or if I needed to out in the field, running off this inverter. Another thing is laptop batteries, tablets, phones, things like that. They can all charge just however you need to. Okay, I'd say this is one of the best things that you can do. This is a 12-volt pump, you know, one of the pumps for like air mattress. So I don't know if you guys have done this. You go car camping, you have your air mattress, and you're like hauling your air mattress out to the truck because you got to pump it up. And then you like carry this huge air mattress back and try to shove it through the tent door and it doesn't fit. Anyway, the best thing about this is you bring your battery box to the tent and you pump up your air mattress in the tent. Awesome having a portable battery. This is just awesome. Anyway, this is another great way that you can use this battery box by pumping up air mattresses. Inner tubes and also pool toys. Everything works, deflates, inflates. It's a great thing to have. Can't forget the hobby stuff. So when you're out running, having some fun with toys, I got my FPV drone here. Hobby charger. Also, what's really cool is this is a 7 amp charger. This is a Trinergy max 80 watt. It balances cells, and it will do lead acid batteries, and it'll also do lithium iron phosphate batteries. Anyway, this is a great thing to bring. 12 volt power. It worked well. And I'd say the last thing that I plan to use are my 12 volt compressor fridges. So I have a couple other videos about these fridges. These are awesome because a fridge here can basically keep your food completely cold or run it as a freezer without any ice. So if you guys are interested more about these fridges, go ahead and check my 11 fridge comparison video up here, or go ahead and check out my reviews. But IceCo, I have worked with them in the past. They make amazing fridges. So this is the IceCo Go 20, and I have the IceCo VL45 and JPC 42. So they're all great fridges. But yeah, the options are kind of unlimited. These lithium iron phosphate batteries can source a lot of amps. I don't really plan to source a ton of amps. You usually want to discharge it max at 1C. So I'd only want to discharge this at 80 amps because these are 80 amp hour cells. So that would be 1C. But I don't really ever plan to discharge it that fast. Most of my uses are just through kind of low amperage items. So anyway, you can use these battery boxes for a ton of things, both camping and emergency preparedness. It's a great thing to have around. Okay, so I just want to talk about charging this battery box. Charging lithium iron phosphate batteries is just a little bit different than lead acid, but because the BMS is built into there, you have some settings that you can put in there. What you want to do is stick to the highest you want to go is 3.65 volts per cell, and that comes out to be 14.6 volts. 3.65 is the upper limit, and after time it does settle a little bit. Right when you use it, it will drop down to 3.3 volts, and it stays at 3.3 for a very long time. So just keep in mind that's kind of where you want to upper charge it, right? So that's really similar to a lead acid battery. And so if you look at this, I have a AC to DC lead acid charger here. It's a 10 amp charger. It works fine. And then the other way I'd plan to charge it is using this solar charge controller. This is an MPPT charge controller I built. There's a video on my channel about that. But basically, I would charge through solar panels or I'd charge the wall, and that's how I plan to charge this. Just keep in mind you want to check the BMS, make sure that the proper settings are in there. You want to make sure it only goes up to 14.6 as a full battery pack voltage, or 3.65 as a high voltage on each cell. Okay guys, well that's kind of everything I wanted to talk about. I guess just a few final things about the battery. Yes, these lithium iron phosphate batteries are a little bit more expensive than lead acid batteries, but the reason I built this myself is because you can source these batteries, the blue cells here, from AliExpress for really cheap. So after reaching out to a ton of sellers, I finally found a seller that I believed was a really high quality seller, and they sold batteries that actually were real cells. So I have where I got the batteries linked in the description below from AliExpress, the store there. They worked great with me and they communicated great. Everything about them, I totally recommend them. They also do have American shipping, so you can get these batteries pretty quick. As for the BMS, I did have to buy this from AliExpress overseas. I could not find an American retailer of AliExpress for this, so that did take a little bit longer to get here. Same with the Bluetooth module. Both the BMS and the Bluetooth module were purchased from the same store. I'll have them linked in the description below, and the cells. So I do feel that I was able to get this for a pretty good overall price. These cells were $3.99. To get something similar to this whole setup, but just the battery, so the battery and BMS and a very long warranty like a Battleborn, for a 100 amp hour cell, you're paying $950. For a 50 amp hour cell, you are going to be spending $500. So building it yourself for $399 plus around $100 for the BMS and wiring, and then just a couple other dollars for the case and the front panel. You know, I will have all the parts linked in the description below so you can get that, but you know, for around $500 you can have this battery up and running, and it has 80 amp hours, so it's 30 amp hours more than what you can get from Battleborn, and I thought it was worth it, so I decided to do it. I love doing DIY projects. This was fun for me. So if you're looking for something that maybe you want to just have a drop-in replacement with a warranty, maybe look at Battleborn. But if you think you're good enough with your hands and projects like this, you know, go ahead and dive in. It really wasn't that bad, and it was really fun to say this is something that I built. So if you guys have any questions or comments, please feel free to let me know. I'm putting out a lot of content like this. I love these electronic projects. I love the 12-volt compressor fridges. It's just something that that I love to do. Anyway, guys, if you like this content, feel free to subscribe to the channel. I got some more stuff coming out soon, and hope you guys can stick around for future videos. Thanks for watching. Have a great day.